In this video, I will show you how to calculate with complex numbers. We will consider the basic operations like addition, subtraction, multiplication, and division. Let's start with addition. We add the two numbers 2 plus 3i and 5 minus 4i. And we add the real parts. 2 plus 5 is 7. And we add the complex parts. 3 plus minus 4 is 3 minus 4 is minus 1. And the result is 7 minus I. Now we subtract the same numbers. 2 plus 3i minus 5 minus 4i. So now 2 minus 5 is minus 3. And 3 minus minus 4 is 3 plus 4 is 7, and we obtain minus 3 plus 7i. Now we come to multiplication. We multiply those two numbers. 2 plus 3i times 5 minus 4i. 2 times 5 is 10. 2 times minus 4i is minus 8i. 3i times 5 is 15i. And 3i times minus 4i is minus 12i squared. 10 minus 8i plus 15i is plus 7i. And I squared is minus 1. So minus 12 times minus 1 is plus 12. Now we add the 10 and the 12 and we obtain 22 plus 7i. On this slide you see two other examples, one for addition and one for multiplication. And it is important that the result of all those calculations is always in the form a plus bi, real part plus imaginary part times I. Now you should stop, at this point you should stop the playback and look at those two examples and try to solve the task. Calculate Z1 minus Z2 and Z1 times Z2. The next operation is conjugation. If Z is the complex number a plus bi, then the conjugate of Z is Z star is a minus bi. So the sign of the imaginary part is just flipped. And the absolute value of the number Z is defined by square root of a square plus b square. And this is always a non-negative real number. Let's look at some examples. The number 2 plus 3i conjugated is 2 minus 3i. The sign of the imaginary part is reversed. And 5 minus 4i conjugated is 5 plus 4i. The absolute value, for instance, of 3 plus 4i is the square root of 3 squared plus 4 squared. Square of the real part plus the square of the imaginary part. And no I. 3 square is 9. And 4 squared is 16. 9 plus 16 is 25. And the square root of 25 is 5. The absolute value of 3 minus 4i is square root of 3 squared. The imaginary part is minus 4. So minus 4 squared. And this is 9. And minus 4 squared is plus 16. So the absolute value of 3 minus 4i is the same as the absolute value of 3 plus 4i. At this point you should stop the playback and calculate the following exercise. The next operation is division. We divide the following numbers: 14 plus 5i divided by 4 minus I. So we expand the fraction. That means we multiply the numerator and the denominator with the same number, and this number is the conjugate complex of the denominator, which is 4 plus I. So we multiply the numerator and the denominator with 4 plus I. So we multiply in the numerator. 14 times 4 is 56. 14 times I is 14I. 5I times 4 is 20I. And 5I times I is 5I squared. I squared is minus 1, so it's minus 5. So in a denominator, we have the third binomial formula. A plus b times a minus b is a squared minus b squared. So we have 4 squared minus I squared. So in the numerator, 56 minus 5 is 51. 14 plus 20 is 34. And 4 squared, I squared is minus 1, so it is 4 squared plus 1, which is 16 plus 1 is 17. So 51 divided by 17 is 3, and 34 divided by 17 is 2. So the result is 3 plus 2i. And remember that the result always must be in this form, a plus bi. So this would not be a correct result. At this point you should stop the video and look at the following example. It's another example for division, and then try to calculate the two tasks.